All right, so on these ones, we are solving trigonometric equations using half-angle identities. So if we look up our formulas, our half-angle formulas, sine of u over 2 would be plus or minus the square root of 1 minus cosine of u over 2. Cosine of u over 2 plus or minus the square root of 1 plus the cosine of u over 2. For tangent, we had 3 different choices depending on which one we want to use and what we want in our formulas. So you want to keep that paper handy. You also want to keep your paper handy with your reference angles and what each of those are equal to that we've used so many times already. So if I go back over here, it has the cosine squared of x over 2. So if I think about what is the cosine of x over 2, it would be plus or minus the square root of 1, and that one is 1 plus the cosine of x over 2. So substituting that in, we're going to have 2 minus 2 cosine squared. So I'm going to have plus or minus the square root of 1 plus the cosine of x over 2, but it's going to be squared, equals the sine squared of x. Now when we square this, we don't have to worry about the plus or minus. It's going to be positive. Squaring that square root's going to cancel that out. So we're going to get 2 minus 2, and we're just going to get the 1 plus the cosine of x over 2, because when we squared that square root, it made it positive and canceled it out. Equals their sine squared of x. So we get 2 minus, this would cancel this, 1 minus the cosine of x, because I use my distributive property, equals my sine squared of x. 2 minus 1 would give me 1 minus the cosine of x. Here, since I have sine squared of x, I want to use my Pythagorean identity. The sine squared of x equals 1 minus the cosine squared of x, so that I have the same units. So I have 1 minus cosine squared of x I can substitute in for sine squared of x. I am going to minus my 1, add my cosine squared of x. So I'm going to have cosine squared of x minus cosine of x equals 0. Factoring that, I would have cosine of x times cosine of x minus 1 equals 0. So either my cosine of x is going to equal 0, or my cosine of x is going to equal positive 1. I am then going to look those values up on my table. So cosine equals 0 is at pi over 2, and also at 3 pi over 2. But those we can combine. So pi over 2 plus k pi, with k being an element of z. Cosine of x equals 1 is at 0. That's it. But we would do plus 2k pi. So we are just going to use 2k pi with k being an element of z, because I don't need the 0 in front. 0 plus 2k pi is just 2k pi. So 2k pi with k being an element of z. So our answers, we either have pi over 2 plus k pi to combine those two into 1, or we have just the 2k pi, because 0 plus 2k pi is still 2k pi, with k being an element of z. So not only did we have to use our half-angle identity, we had to use one of our Pythagorean identities to substitute in order to solve that all the way. The next one, we're using a sine. So we have the sine, whoop. Now the board's going to be difficult. The sine of x over 2 is going to be plus or minus the square root of 1 minus the cosine of x over 2. If you look up your half-angle identity on that one. So we're going to do 2 minus 2 plus or minus the square root of 1 minus the cosine of x over 2, but we're going to square it. equals 2 sine squared of x. So again, when you square this, it'll be positive. Cancel out your square root. So 2 minus 2 times 1 minus the cosine of x over 2 equals 2 sine squared of x. 2's are going to cancel. 2, this is minus, so minus 1, negative times a negative would make that plus cosine of x equals 2 sine squared of x. 2 minus 1 would be 1 plus the cosine of x. Again, here we're going to want to use our Pythagorean identity. The sine squared of x equals sine squared of x equals 1 minus the cosine squared of x. So I'm going to have 2 times 1 minus the cosine squared of x. So 1 plus the cosine of x equals 2 minus 2 cosine squared of x. Moving these over here, I'm going to subtract my 2 and add my 2 cosine squared of x. So 2 cosine squared of x plus the cosine of x minus 1 would equal 0 when I combine all my terms. 1 minus 2 would be my minus 1. So factoring that, I have 2 cosine squared, so 2 cosine of x times the cosine of x. End is negative, so one's a plus and one's a minus. We got a plus here and a minus here because factors of 1 are 1 and 1, and we want a plus 1 in the middle. So we want a positive 2 cosine of x minus 1. 2 minus 1 gives me the positive 1 cosine of x in the middle. So 2 cosine of x equals 1. Cosine of x would equal 1/2. Here, cosine of x would equal negative 1. Looking those up on our table. Cosine of x equals 1/2 at pi over 3. Cosine of x also equals 1/2 at 5 pi over 3. Those are not 180 degrees apart, so they're both going to have the 2k pi. Cosine of x equals negative 1. The only place cosine of x equals negative 1 is pi. And so we're going to have to add the 2k pi to that. So we're either going to have pi over 3 plus 2k pi, or 5 pi over 3 plus 2k pi, or pi plus 2k pi. And so all three of those are going to go in for your answer. Pi over 3 plus 2k pi, 5 pi over 3 plus 2k pi, or just pi plus 2k pi, since that's the only place cosine equals negative 1. One more on this sheet. Okay, so number 18, again we're using the half angle formula for sine of x over 2. Sine of x over 2 is plus or minus the square root of 1 minus the cosine of x over 2. So 1 minus 2 times plus or minus the square root of 1 minus the cosine of x over 2 squared equals cosine squared of x. So in this case, 1 minus 2, squaring the square root would make that positive, so I just get the 1 minus the cosine of x over 2, because the square root would cancel out, equals cosine squared of x. Here my 2's would cancel. So 1 minus 1 plus cosine of x, negative times a negative made that a positive, equals cosine squared of x. Since we're all in terms of cosine, we don't need to use our Pythagorean identity. We just need to set it equal to 0. So 0 equals the cosine squared of x minus the cosine of x. 1 minus 1 would have canceled out. Factoring, we can take out a cosine of x. So we have cosine of x minus 1. And so either cosine of x equals 0 or cosine of x equals a positive 1. So looking up where the cosine equals 0. Pi over 2 and 3 pi over 2. Again, those two are ones you can combine. They're 180 degrees apart. So pi over 2 plus just k pi, with k being an element of z. Cosine of x equals 1. Cosine of x equals 1 at 0. So 0 plus 2k pi just gives us 2k pi, with k being an element of z. So again here we can combine those into 2. They're 180 degrees apart, or pi apart. Here you have 0 plus 2k pi. You don't need the 0 in front. So those are going to be my answers. And that is the end of Chapter 6, Homework Day 31.